Okay, so start your question.
So I was asking that I want to get this right. Caves, Christensen, and Diewert use the productivity analysis and then Färe efficiency to introduce Malmquist productivity. But then it was Färe, Grosskopf, Lindgren, and Roos in 1992 who popularized it. And it was named after, the productivity score was named after Malmquist in 1952. I want to know if what I just said is right.
Yeah,
or there's more to
it's in 1950. I thought it's 1951.
51.
Yeah, just double check. So yes, Caves brought it, and when he brought it, it was not, they were not using linear programming for it. And Färe, Lindgren, Grosskopf, Lindgren, and Roos, and later, of course, 2 years later, Färe, Grosskopf, Norris, and Zhang. Okay, these guys, these sharp guys, you adapted the data envelopment analysis, which has already been introduced by CCR in 1978. Okay, because if you look at the timing, okay, the timing that the productivity was actually brought was 82. And of course, he wrote some other papers before, CCD, and then Christensen himself and Diewert later. So when these guys brought about the linear programming efficiency analysis in 1978, this was already running when this productivity was brought in. So Färe and his team actually decided to adapt the linear programming optimization method in DEA as one way to calculate the productivity. And also, not just one way, but also to generalize it. Generalize it because it wasn't just single input and single output, but also multiple input, multiple outputs in this case. And because the technique of DEA was already there, this thing became a DEA-based Malmquist index in that 92 and 94. But that is not to say that the Malmquist was already also happening in SFA, in stochastic frontier analysis. You know, Nishimizu and Page in 82 had already introduced the Malmquist in the regression world. But then in the DE world, this is a history. Now, I think this history has been well explained in the book by Tone. I don't know, I forgot. I think it's Tone 2004. You know, he was writing a portion of the book. And then the book by Cooper 2011 also brings about the history. But then you're quite right about what you said. And it's also good, like you just indicated, it's also good to bring a bit about this history before you actually talk about Malmquist. It's good to know. Because somebody doesn't even know that word Malmquist is somebody's name. You know that?
Yes, Doc.
Yes, Doc.
Somebody doesn't know that it's Professor Sten Malmquist. You know, so it's good to bring a bit of this history before you move. Anyway, let's go to our...
Doc.
Yes.
Doc, please, before you go on, when I was doing my taxonomy, I noticed that most people use they write Malmquist DEA as their methodology. The question is, I know the two of them are not the same thing. So why is it that they do not write the Malmquist separately from the DEA and they combine it as one? Okay. So they combine it basically because they are going to use DEA to estimate the Malmquist index. Normally, there are other groups of people who use stochastic frontier analysis to estimate the Malmquist, another methodology on regression. And so normally when these people want to distinguish that SFA Malmquist from the DEA Malmquist, that is why they will be saying DEA Malmquist. Okay, sir. But normally it's a term, they will normally use it once and then they will not be saying it again. So further to that, after that, they will say Malmquist index, Malmquist index, Malmquist index, because they've already told you that they are using DEA Malmquist already. Okay, sir. Thank
All
you.
right, so if you look at this data set, it's the same data set for year 1 and year 2, but now we have seen that we have year 3 and year 4 in the data set. So this is actually becoming, multi-dimensional, time dimensional. It is because the dimensions are increasing, time dimensions are increasing, and therefore we can now do a lot of patterns and trends and productivity changes. So that is good. Now we are going to draw that data set that we had. Okay, we've already drawn this one. We've already drawn this, okay, for year 1 and year 2, the VRS frontier. Now I'm going to ignore the CRS frontier so that the thing doesn't become complex. So I'm going to add the year 3 drawing and the year 4 drawing. Okay, which of you did it? Which of you were able to do that drawing?
Yes, Doc. I'll attempt it.
I did it.
Yeah, Benis, you did all of it, didn't you? Who did all of it?
Me, Doc. I did all.
I did all of it.
Did all. Okay, so you should all have something like this.
Yes,
I'm
Doc.
sure that was
Yes,
a very lovely exercise you did. A very lovely exercise. Drawing. See, these drawings might look like, oh, I can do it, I can do it, I can do it, I can do it. But when you start doing it, how did you feel? Kizito? Was it so smooth and easy?
No, I think it's minutious. You have to take your time, draw every year by year, and by doing that you can have this drawing. But if you plot all the data set at the same time, you will be lost. So me,
Okay, so
I
you
did
did it one by one.
Yes.
Okay.
Yes.
I did this all at the same time too.
Hey,
Oh,
Doc.
you are super efficient.
I also did all at the same time.
Yeah, that's the best way to go. And then you can now, when you put the cursor on it, it will tell you the number. And then you can now start showing different markers for the number. Anyway, you can see that I'm using times for the red ones. I'm using a plus for the black lines. And then I'm using triangle for the green ones. And you can see that if I use green, that's the same one I'll use to draw the same color I'll use to draw. And if you look at the blue, I'm using the diamond, symbols for that. Okay. And when you are labeling them, label the names of the frontier on the far end, like I've done here on the far end. It's very important to consider all of this. Okay. Now, you can see that the frontiers are not Higgs neutral. They are intersecting each other and several things, okay? So on the basis of that, it means that when you are estimating these frontiers, there will be some overlaps. There will be infeasibilities. There will be there will be efficiency, super efficiency, inefficiency, and even infeasibility. Now, the levels of this, you got to note. You got to note these levels a lot, okay? Let me just show you. So you got to know the names that we normally assign. Oops, just a second. You got to know the names that we assign to this in that order. First, inefficient. That's the lowest level. Next, efficient. That is the next level. Next, super efficient. And then finally, infeasible. Now, guys, listen to this. Under VRS, you will have all of these. Under VRS, you have all of these. Now, my question to you is this. Under CRS, which one of these will you have? And which one of these will you not have? You can tell me. Under CRS, which one of these will you have and which one will you not have?
Look, I think we can have under CRS efficient, inefficient, but not super efficient and infeasible.
Nice try, but no. Yes, who else? Now, these are deep things.
Doug,
Mm-hmm.
under CRS, you can't have infeasibility, but you can have efficient, inefficient, and super efficient.
That's a perfect answer. So under CRS, you can only have inefficient, efficient, and then super efficient, but no infeasibility. No infeasibility. And that is key. This is key when you are estimating the multi-directional efficiency that we'll look at. Okay. This is key when you're looking at the global Malmquist. Okay. Very important to understand this. Now, which one of these is a problem? You all know it. Which one of these is a problem? Well, it depends. It depends. Inefficiency is a problem. No. Infeasibility is a problem. So again, it depends. So what we are going to do is that we're going to estimate not only the own period, but also the cross period of each firm in this industry. This is an industry with 4-year panel, and it's an industry that is having 5 firms. Now, there's something you didn't see it here, but it's here, that I want you to take note. It is a fact that all the firms are 5 in each year. So what sample is that?
Balance.
Balance. But I can tell you with an authority that eventually I decided to make the last one, and I think I didn't show it here, but then I decided to make the last one not 5, but 7. So the last one is not 5, but 7. I brought it later. Okay, it's not here. I brought it later. So I want you to take note. So the last 5, you will see F and G. Only for the last one. Only for the last one, F and G. Because I wanted you to see how they handle infeasibility. Sorry, how they handle unbalancedness. Because unbalancedness is very important. Yes. Okay. Now, how do you estimate Malmquist, first of all? We are dealing with Malmquist first now. There's time, don't look at the others. But how do you deal with Malmquist? So we're going to see how you can do Malmquist productivity of. Okay, so going back to your question, Michael. So the Malmquist productivity change index is technically attributable to who? Which authors? Based on all your readings. Who are the authors who mention the Malmquist index?
Technically, is attributed to Färe, Grosskopf, Lindgren, and Roos.
That is it. Okay. So that is it. And that is what you see on it. So for this purpose, we'll be calling it the classical Malmquist. Guys, I want you to take note of the formulae I'm about to show you. It can be slightly confusing, but I want you to take note. For me, the formulae are important. Now, watch this, that every formula I show you, every formula that I show you, the score you see there, for example, the score I've just circled, the score you see is actually an efficiency score. And this efficiency score itself has to be formulated, okay, like maximize theta, blah, 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 subject to all of these. You've done it already. But I want you to know that each one must be formulated. And the formulations differ in 3 ways. 1, The formulations differ depending on whether you are doing input orientation. So you differ in terms of thinking forward, in orientation. The formulations will differ depending on orientation. The formulations will differ in terms of the period, whether you are dealing with cross period or own period. The formulations differ in terms of whether you are dealing with global or biennial. Or frontier. The formulations will differ. So I'm just telling you that the formulations will differ. So what I'm just showing you right here, the little I'm showing you right here at the top, that is not all of it. You have to now learn how to maximize and minimize this objective function and to be able to come out with a score that we are looking at. Okay. The next thing I want you to take note is the fact that you've already known that the Malmquist is made up of 4 different efficiency scores. So this is the Malmquist of Färe, Grosskopf, Lindgren, and rules. This is the Malmquist. It's under constant returns to scale. It is made up of 4 different efficiency scores. What are they? This is the first one, this is the second one, this is the third one, this is the fourth one. And then finally, you see that we have the geometric mean. You take the geo mean or the square root. 4 different efficiency scores. I want you to watch the way these are actually written. Watch the way they are actually written. Watch it carefully. You will notice that the own period efficiency scores are in the right diagonal. The own period are in the right diagonal. And then the cross period efficiency scores are in the left diagonal. Oh, sorry. The left, the own period efficiency scores are in the left diagonal. Then the cross are in the right diagonal. So the own periods are from left to right, downwards, left to right, downwards. And then the cross periods are from left to right, upward, left to right, upward. 4 different efficiency scores. That's all you need actually to calculate the Malmquist and decompose that Malmquist. 4 scores. 4 scores. Once you have these 4 scores, you can get all the necessary parts that you want to have. Now, that is a Malmquist. But then according to Färe, Grosskopf, Lindgren rules, this Malmquist scores, this score, this one score, which we are called MC, okay, that score can be split into 2. And you should go and do your own exercise and know how we factorized it into 2. How do you factorize it? Watch it. You factorize this thing by taking this top part there and this down part here out. That is how you factorize it. So you take the own period out. So your own period in year 1, okay, that's what you take out. Own period in year 1, and then the own period in year 2 should come under it. So you've brought those out. And then you ask yourself, what do I have to multiply them by so that I will get back my original Malmquist? Well, if I multiply them by this value here, the same own period, but this time for year 2. So I just need the same own period, but this time for year 2. And then on the right section, I need that same own period, but this time for year 1. And I need the cross period, okay, for year 2, and then the cross period for year 1 also above here. If I do that and I cross multiply, what do I get? Well, if you cross multiply, if you expand this, you can see that if you multiply this first part here by this one, you see that you're going to have this cancel that. The own period will cancel, and you rather be left with the OW1. And you will eventually get back the Malmquist. Guys, are you following me?
Yes, Doc. Good.
So you should learn how to do that cross multiplication point to get back the original Malmquist. That's all I'm trying to say. Don't just look at the decompositions like that. And note that the Färe Grosskopf Lindgren decomposition is constant returns. That's why you see C, subscript C, subscript C, subscript C, subscript C, subscript C. Anytime you have that subscript C, 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 it is constant returns. And that will not suffer from infeasibility. There's a lot of argument to go with that. Okay. Ray and Desli, Willock and Wilson, Ray, Grosskopf, most of these arguments saying that choose the Malmquist and the constant returns because it doesn't suffer from mixed period linear programming infeasibilities. That's why. Okay. But now you're going to see that we have solutions to all of this. So you should know the two-factor decomposition of the Malmquist, which is constant returns. Note, the two-factor decomposition is constant returns. It's constant returns. It's constant returns. Now, the three-factor decomposition, there are other three-factor decompositions. But then, here I'm focusing on only two of them. Färe, Grosskopf, Norris, and Zhang created a three-factor decomposition. In all of them, note something. You can see that because it's now three-factor decomposition, anything above two-factor decomposition is said to be VRS, variable returns. And so when we come to even the efficiency change, we call it pure efficiency change. Anytime you see the word pure, it means that there is a variable returns that has been introduced. And to do that, you will notice that there is V here. All of the variable returns will have V. And they will have names like pure. Pure is always for variable. So the same efficiency change, but this time is pure managerial efficiency change. This is what we call managerial efficiency change. Then this second part here, the PTC, is also pure technological change. Now, for you to know that it's pure, anything that is pure will have a V. So you can see that it has a V there, it has a V there, it has a V there. Anytime something is pure, it has a V there. It's not mixed with V and C. No, it's pure V. Then when you come to the latter part, which is the scale efficiency, this one there, the scale efficiency is always having C and V. It's always having C and V. So you can see that this is V, that is V, but this is C, and that is C. So it's always a ratio of the V and C, the scale efficiency. Now, this is the scale efficiency of Färe, Grosskopf, Norris, and Zhang. And again, when you manipulate these things, you get back, which was later criticized. Now, why was it criticized? It was criticized because, and again, the first person to do that criticism is Ray and Desli, 1997, in the American Economic Review. What they said is that there's a lot of inconsistencies in there. How can you be using V for this, for the PTC? And then when it comes to the SEC, now you are mixing constant returns versus variable returns. That's what they are saying. Why are you mixing constant returns versus variable returns? But when it comes to the PTC, that one you are using V. But when it comes to the scale efficiency change, by the way, this is called scale efficiency change. This time you are mixing the variable returns and the constant returns. So they introduced a new version. They introduced a new decomposition. And that decomposition, ladies and gentlemen, is what is known as a Ray and Desli decomposition. That's here. That's a Ray and Desli decomposition. So at the top, you will see that decomposition. The pure efficiency change doesn't change. And again, you want to pay attention here because this can be tricky sometimes. Okay, so you can see that the pure efficiency change, that one still remains as the original one. But The variable returns to scale, that is also remaining the same thing. Okay. The V is there, the V is there, the V is there, and then the V is there. But when it comes to the scale change, they call it, okay, they measured the scale part not only between V and C in own period. And again, if the best way to understand this is when we go back here. Watch it. When you look at this, they measured the scale efficiency change, okay, all of them in own periods. Do you guys see the own periods values? Do you guys see? They are all own periods.
Yes, Doc.
Just want to, if you can understand this, you can understand a lot of things. Okay. Oh, by the way, the one who said yes, please, how do you know that they are all own periods? Miriam, tell us. How are they all own periods? Miriam, are you there?
Yes, Doc.
Why you said that yes without knowing exactly why? Eh? Can somebody tell me why all of these are own periods? How?
Doc, it's because the numerator is a cross period and the denominator is an own period.
No, no, not at all.
Doc.
Yes.
As because the input and output in a particular period are being assessed using their frontier, that period's frontier. As we can see in the numerator, we have the frontier t+1, and then the input and output are t+1. But then the denominator, we have just the frontier t, and input and output are frontiers tt.
That's
the same
it.
Frontier t.
That's it. So the key point is that the frontiers are in the same period as the DMUs. That's the whole point. Own period. The frontiers. What are the frontiers? The frontiers are these ones, the ones outside the brackets. The frontiers are in the same period as the DMUs, the ones in the brackets. If you don't write these things down, you tend to miss them. If I ask you again next time, you miss it, you lose it. The frontiers are in the same period, or the DMUs are in the same period as the frontiers. So what he did, what Färe, Grosskopf, Norris, and Zhang did is that they did not consider cross periods here. And Ray Desli, in the AME paper, said, no, you cannot do that. You cannot do that and ignore the cross periods. You're only using own periods, but scale efficiency incorporates both periods. You see, scale is looking at how you are doing between your constant and then your variable, but in a cross dimension, in a cross period. And so what they did is that they now introduce this very one. Okay. And what is the difference between this very one and the previous one? Well, obvious. You can see that in this very one, in this, there is not just cross own period. You can see own period, own period, own period, okay, own period, own period, own period. Just as this one, just as the previous one, okay, own period. But then when it comes to the bottom, you can see that now there's cross period with own. So between this and that, there is cross period. Between this and that too, there is cross period there. And then here, you still have your own period, but above it, there is also cross period. So scale change formula here was seen as a better one. Better one. Which itself can be split. The scale change itself, guys, follow me here, can be split into what? Who can tell me? The scale change itself can be split into what? Christopher, are you there?
Doc.
Yes.
I think it can be split into Scale efficiency change and scale technical change.
Remember, I told you that in order not to get yourself confused, that word, you should use the proper word. So say it again. Can I split into what?
I said scale efficiency change and scale technical change.
Scale technological change.
Technological, sorry.
Good. So the scale change can be split into the scale efficiency change. Which one is that? The scale efficiency change of Färe, Grosskopf, Norris, and Zhang. And then scale technological change of Wheelock and Wilson. And that Wheelock and Wilson one is what you see down there. The scale technological change, that is it. The scale efficiency change, that is that. So if you multiply the two, you should get back Ray and Desli scale change. Are you guys with me so far?
Yes,
but I can ask you a question. What is the difference between the scale change of Ray and Desli and then the scale technological change of Wheelock and Wilson? Go and check it and you see that there's a beautiful difference, between the two. Beautiful. Well, the thing is that you need something in addition to the STC of Wheelock and Wilson to get the scale change of Ray and Desli. Guys, most of the decomposition you guys are going to do, you're going to take the Wheelock and Wilson one. This 4-part decomposition. And the last time I was able to explain to you the difference between the scale technological change and the scale efficiency change. You should continue to remember it and to understand. I also gave you a book by Clark, a paper by Clark for you to go and read. Do you all remember?
Yes, sir. Clark, it's all 1996.
Have you got to that paper?
Yes.
You see, that paper talks a lot about R&D, learning by doing, things related to technological change. Read it, incorporate the principles from there when you are writing. Because you got to understand each of these components. Let me guide you. Each of these components, you must understand each one of them fully, conceptually, practically, and example-wise. Okay. You got to understand them practically, how they apply, what they really mean in real market systems. You got to understand them. So that is a Malmquist. And we should be able to now estimate this Malmquist at this stage. How do you estimate the Malmquist? You are supposed to estimate this Malmquist for all the years, all the 4 years. Okay. I wanted to do the global Malmquist, which is the next one, but I'll hold on a bit for that. Okay. What I'm interested in is your capacity to estimate this Malmquist using R, since you have drawn it all already, using R, and then fit them into this formula. Fit them into the formula. Okay. And after fitting them into the formula, you should be able to now come out with a real beautiful, beautiful result. Can you do that? That's what we're going to be doing next. Okay, so that data set, I've started that data set that you had, which was 4 different years. Okay, that data set you had is changed. What do I mean by it's changed? We are now going to run the entire scores in R. We're going to estimate Malmquist. We're going to do the 1-factor decomposition. We're going to do the 2-factor decomposition. We're going to do the 3-factor decomposition. And finally, we are going to do even the 4-factor decomposition. We're going to do all of that right here, right now. I want you to look at the data. Now, I'm showing you the data here. Look at the data set. And there's something I want you to take note of the data set. What do you see in the data set which might be different from your own? Getting to the bottom, what do you see?
Doc, the bottom has 7, 1, 2, 3, 4, 5, 6, 7 or 8. 7.
Yeah.
The panel has now changed from a balanced one to unbalanced because of the last year.
So the same thing, what I want you to do, I want you to add the same thing, you know, those last two DMUs, I want you to add them to your work. Now you can see that I have plotted them somewhere here. That's what I've done. You can see that I have plotted them here. Let me make it. I have plotted them. F and then G. So they didn't appear in any year. All of a sudden, they joined the industry. And I've plotted them there. So what I want you to do is that in your Excel, incorporate those two DMUs. And when you are done, let me know. Just say you're done. In your
Please
Excel.
show us this.
Sorry?
Look, I'm done.
The score so that we can input it.
Okay, the X are 8 and the Y is 3. So it's 8 and 3. And they are in year 4. And then the G is 13 and 5. So 8, 3, 13,
okay. 5. I'm done.
All right. So we are going to copy this data. Now that we're done, we'll copy the entire data set, the whole thing, as you can see I've done. Copy the entire data set. And then come to R, open R. So this is our R. We are now inside the R. Okay, we are going to run the data. But before we run, there are some few things. Don't copy, don't save anything, because what you have copied is on your clipboard. Before you actually start, you have to, because we want to do 4-factor decomposition straight away, we are going to use the package known as Färe. You can use benchmarking, just that the benchmarking will require you to do a lot of commanding. So we are going to use Färe. And Färe, when you go to packages on the far right here and you click on packages, some of you will not see packages. So I've done a video on how to have Färe. Some of you will not see Färe. So I've done a video, and this is a video. Watch, command number 61 is saying that watch the video. And I've given you the YouTube link. So you will watch that video, and that video will show you how to install Färe and bring it here. So I'm going to assume that you have Färe. Now, if you have Färe, all you have to do is take it. You can either take it here, or you can come to command number 59 and run that command. Okay. So let's take it. When you take, it will tell you at the bottom of the console, look at the console here. At the bottom of the console, it will tell you that Färe, Frontier Efficiency Analysis with R version 3.1 is installed. The copyright is Paul W. Wilson 2020. Okay. So you get all of that. If you want to know the license, you can type this command and get a license instruction. If you want to know how to cite it, you can type this command and then you know how to cite it. All right. Now, Färe is inside. We are ready now to, the data set we copied, we are ready to load it into R. So while the 10 is still copied on a clipboard, even though you don't see, command number 62, run that. And once you run that and you come down and look at the console, you will see that the console is turned blue, which means that the data you copied from the Excel has been beautifully loaded into the memory of R. And the command that did that was command E. It is an easy copy-paste command, but you don't paste in R. It's copy-run command. So that will import the full data set. And guys, note, this is the same way you will import your real-life data set. Even if you have 200,000 observations, this is the same way you can bring it into R. You can do Control-A to highlight, Control-C to copy, come and use a command. You see, I use the command E because it's easy to work with single letters, double letters, than if I had written elementary. That's the name of the data in R. Come on, elementary, that's too long. So it's good to use short letters. 1 or 2 letters is fine. Sometimes data. Okay, data is even the longest one. It has 4 letters. Sometimes that. Sometimes D. No, I use E. Anyway, so that is a command. It is loaded. To know that the data is loaded, just highlight E and click run or run it. You see at the bottom here, the data is all loaded, including the F and the G. And R is telling you the number of observations as well. So now you have 22 observations, 5 in the first year, 5 in the second year, 5 in the third year, 7 in the final year. Excellent. Yeah. Please note that I use small letters throughout at the headings. It's always good to keep things simple. So DMU, year, X, and Y, they are all small letters. If yours are not small letters, be careful. Okay. Keeping it all as small letters doesn't complicate. All right. So now we can go and run command number 63 to create a matrix of the input. Now, in this case, the inputs that we have is only one, X, and it is in small letter. But imagine that we have inputs like, no, imagine we have inputs, X1. Imagine we have input X1, input X2, input X3, input X4, input X5, input X6, and so forth. Now, we can combine all of them together and call it input X, capital. Okay, and that is what I'm doing here. Okay. It's just happened that ours is just one, but in real life, you have more than one input. So this command is saying that I want you to combine, and I'm using robind here. I want you to combine the inputs. And where are the inputs? The inputs are X's, which is inside the data called E. So it is E.X. Okay. The X's inside the data called E. I want you to combine them. And remember that the number of rows you're going to get for that is 1. Okay. Now, and it's 1 because the inputs are only 1. That's it. Who can tell me why this X, capital X, is X1 instead of X, capital X? Who can tell me why is this capital X, X1 instead of X?
Oh, I think because X1 is a matrix.
Not really.
And the small.
My question
for
yes?
the period.
Who's talking?
The input for period 1. So this is Prince.
Say that again,
so
Prince.
The one is for the year, the period.
Exactly. That is
the
it.
one is for the year, the period.
So the one here is referring to the year. It's not referring to the X1 because there is no X1. So I just want you to know that even if there is X1 or X2 or X3, you will still combine it all and call it X1, where capital X1, of course, where that X1 is referring to the year 1. I want you to take note. So what this one is doing is that we are combining all the year 1 inputs. It doesn't matter how they have been named. They can be named deposits, they can be named input, labor, they can be named capital. Deposit, labor, capital, all combined into X1 in year 1. That's it. All the inputs have been combined. So if there were other ones, how would we have written it? If there were other ones, because to be honest with you, that is exactly the same thing you are going to have. So it's important that you know what it is. If there were, other input like X1, X2, X3, how would we have written it? By the way, let me show you the Excel. This is an Excel. And if you look at the input, we've written it only as X, not as X1, X2, X. And so my question is, as if there were X1, X2, X3, okay, okay, suppose, let me bring you back here. Suppose there were, suppose there were 2 inputs, okay, instead of the 1 input here. Suppose there were 2 inputs. Who can tell me how would we have written it? And the input were X1 and then X2. How would we have written it?
Doc, with a C bind, what's in the bracket? That's the E dollar.
There's nothing called C bind here.
It's R bind.
It's R bind.
Sorry.
We are combining them across rows. It's row bind.
For this one, we just have E dollar X 1 to 5 in there. If the X's were many, say X1, X2, X3, then it's going to be.
Let's say with only X1 and X2. How would you have done the whole thing?
Okay, so after the R bind, the E dollar X would have been E dollar X1 1 to 5, comma, you open another bracket, E dollar X2 1 to 5.
And then
exactly.
And what happens to the row?
The row is still 1 because you are combining it into 1.
No. No. By the way, when you say you come out of the bracket, you have to come out of the square bracket, not a bracket.
Yeah.
It's a square bracket. So if there were 2, it would have been X1 like this, X1, okay. Then let me just copy this one. And then come out of this square bracket and then make it E dollar X2 1 to 5, which is what you probably wanted. But then the number of rows now have to change because the rows are no longer 1 for the input, they become 2. Does it make sense?
Yes, sir, it does.
Because remember, we are dealing with rows. We are working along rows, not along columns. And of course, even if it's columns, what you're doing is that you're turning columns into rows anyway. So the number, look at n row. What does n row mean? N row means the number of rows. So what it means is that you will normally have your data set in columns, X1 column, X2 column. But when it comes here, you are turning it. You're not making them column, you're making them row. Because that's how Färe is going to accept them in a matrix. So we now have a matrix called X1, X in year 1, dealing with all the X's. So this is how it should be. If there were 3 inputs, the number of rows would change to what? 3. And then the name of each input is brought in there. Michael, do you get it now?
Yes, Doc, I do.
Okay. So at this stage, we just keep it like this. Okay. Now, you can see that I'm also doing, and what I'm teaching you is very important because it's going to make it easier for you not to be writing everything. Okay. There are 2 ways of handling this. This is one way I'm doing it for you because now this one way, the information is short. The information is short. Do you know that even though I have copied all the data sets, I'm only using year 1 and year 2 data? Do you realize that?
Yes.
Yes.
So the year 3 and year 4 data are irrelevant. I'm not using them now. So I could have just put year 1 and year 2 data in one Excel sheet and just copy only that one. And then put year 2 and year 3 in another Excel sheet. Because you do 2 years at a time. And then put year 3 and year 4 in another Excel sheet. And then copy each one by one and just come and get the results and take them back. Let's do the first one for you to see. So You now understand the X1. What does the X2 mean? What does the 2 here mean for the X2? Capital X2. Christabel, what does the 2 mean?
Doc, please, it means that the time period is year 2.
Good. Now you can see that when it came to the matrix, you now have 6 to 10. Why 6 to 10? You can tell me.
Because, yes, sir.
Go ahead.
Because the first time period ended at 5, and the second one began from 6 to 10. So you want to show that all the DMUs that are from the 6 to 10 are in the second time period and not the first.
Exactly. And you can see that what we are doing here is that we do for the input for both year 1 and 2 first, before we go to the output for year 1 and 2. That's how it is. Create the input matrices for year 1 and 2, create the output matrices for year 1 and 2, and then create the DMUs for year 1 and 2. Okay. When it comes to the Y1 and the Y2, it's just a matter of copying what is here and there, because whatever thing that is in the bracket will not change. All that will change is the letter Y for each one of them. If it is Y1, Y2, Y3, whatever, that's what to change. So you should learn how to create. Look, sometimes your model doesn't work and sometimes comes from here. I quite remember Selena had a similar problem. She was struggling, and then she just realized that there was some dollar she didn't bring somewhere. So check typos. The ID1 and the ID2 must be brought because it tells R, the Färe package, that the number of DMUs inside the data set in year 1 is this. The number of DMUs inside the data set in year 2 is also from 6 to 10. So that's what you tell that. And then once you are done with that, you now run your model. And watch something here, something very important here. Now, the 69 is the main Malmquist, but it gives you the content. The content, not the scores, not the estimation, not the changes. Good. Not the Malmquist changes, but then the contents. The contents. In fact, I would say that even this terminology is quite slightly ambiguous, but the contents. The contents. Let me just see if I can squeeze this slide. Sometimes I normally don't want these things to be taking much of space. So, all right. So this command, which you all have, it says Malmquist. I could have changed it and call it M, but I made it MM. Malmquist.components. Now we're going to run that command, and there's something you should note here. What if you were doing bootstrapping? Okay, what would have happened? Yes.
Look, please expand your, I think, zoom your screen.
Are you using your laptop?
Yes, please.
I've made it a bit bigger for you. Let me know if it's okay.
Yeah, much better now. Thank you.
All right. So this Malmquist.components, first, this X1 is the input matrix for year 1. Y1, watch it. I didn't bring X1 and then X2 first. No, I brought X1 first, then Y1. So I handle all the year 1, both the input, the output, and then the index, the technology index. Then I continue with the year 2 before the orientation. Orientation, when it is 2. And again, anytime you're doing this and you're having a challenge, you remember you have the Färe there, frontier efficiency package, you have them there. So anytime you are worried, you can just click on the Färe. I have it here. you can click on Färe. Once you click on Färe, it will give you the help. And when you are the help, you can now go and search for Malmquist or whatever you're looking for. Here we are dealing with the Malmquist component. Click on Malmquist component, scroll down, and whatever you are seeing, it is telling you. It will tell you what each one of them meant. So for example, you want to know about orientation. Scroll down, that's orientation. Okay. It indicates, it tells you what it means. It indicates direction to which the efficiency is being evaluated. And it tells you 1 is for input orientation, 2 is for output orientation, 3 is for hyperbolic orientation. So you're able to know, okay, which orientation you're dealing with. Sometimes you can type the word out and it will give you that. Instead of writing 2, you can type out. I'll check it very soon and then see whether that is workable. And then you can add the number of bootstrap replications. You see, it says this one is optional. So if you're doing bootstrapping, you will add the number of bootstrap replications to be performed for bootstrapping. Okay. I'm adding all of these to it because I might not get time to teach you all of them again. Okay, so what do I mean by adding the number of, the number of bootstrap replications? So if you happen to, be doing bootstrapping, right, and you want to do a bootstrapping of the results, what you can do is that you can add n rep, and I'm going to add that here, just so you know. You can add n rep. So instead of after the orientation, let us do, or even before orientation, let's do n rep equal to 0. Equal to 0 is the number of bootstrap replications. Sometimes it doesn't like the word equal to 0, but we're going to do that and see. Okay. And then that will give you, but normally you're going to read the literature, you're going to see that approximate bootstrapping 2000 replication is the ideal one. 2000 replication. Replication, n rep is a number of replications, and the replications in your repetition. So you are doing a simulation, sampling weights replacement, you know, and then you resample 2000 times and get pseudo samples and then pseudo bootstrap samples, and then based on that you calculate the bootstrap. We'll look at the bootstrap later, but I just want to know that it's just a matter of understanding and putting into the value. All right, so we are going to run our commands. Since I've done command number 62, we're going to run all our matrices. X1, let's run them. X1 is down, X2 down, Y1 down, Y2, ID1, ID2. And then we are going to run the Malmquist command number 69. Okay, so that is what we've run. And we've gotten something. Now, in order to know the components, whatever you see down here, the warning, just ignore it for now. Just go to the components and just highlight the MM that you've just run. And highlight it and run only that one. It will show you the results you have observed. I hope you are doing it all.
Yes, Doc.
So,
Doc,
my
ID1 is giving me error. Oh,
go
wait,
to the
I've
ID1
seen my
itself.
mistake. I've seen my mistake.
Good,
Doc.
it's good you've seen it. So that's the first step to learning. So when you run the MM, it will give you the scores, the following scores. And what are the scores? These are the scores. The first score you are going to have here is, as you can see, is a VRS scores. Okay, so this is what you have first. B11, B22, B. So these are VRS scores. Following that, they are all components. Then C, constant returns to scale scores. Okay, so the VRS, the V11, if you go and check the top there, okay, the value is 1. V22, V11 For the first firm is 1. Second firm is 0.871. Okay. 0.871. And then the third one is 0.5. And then finally, 1.1. These are the own period efficiency scores. But the way they have been arranged, they don't look nice. So we'll later create a data frame to make it look nice. But I just want you to know that these only give you the efficiency scores, nothing else, the content, the components. Yes, Kizito.
Yes, please, Doc. I'm not getting the same results.
Yes, so you should be able to find out what problem. You see, normally these problems come up because the person did not, follow probably exactly the point, and there are mistakes somewhere. So the first one, your B11, what did you get?
I got 1 and 0.7058825.
You don't say 1 and 0.705. It's 1.7. So say it well and let me hear.
The first one, I got 1. The same thing for you. And after 1, I got 0.71.
Okay. So let's go and see the problem you did. Okay. Because normally when you encounter this problem, the best is when I'm by you. Then I can quickly detect what the problem is. Okay. But check your data. That's the first thing I will tell you to do.
Yes.
Check your data. Check your data and mention your DMUs for me from year 1. Mention them one by one. Forget about the DMU name and year. Just mention the X for me.
Okay.
X and Y. X and Y. Don't look at mine. Tell me yours.
Okay. 4, 5, 12, 12, 11, 17, 11, 14,
Stop.
6,
So
9.
you see,
It's 11.7.
That's what I said. It's 11.7. You made it 11.17.
Okay. Okay.
No, but that is
Okay,
not
so,
the case. The case is that is usually what happens. Now, how your ability to be able to detect that problem, which is what I did right now, is a skill. Like, how come I said, go and show me your data? Instead of saying, show me your command. Because I can see that the problem will surely come from the data. How you detect, how I detected that comes from experience. So again, you got to be able to look at some key points when you have problems. And imagine this was your own data generated and you were wrong. You cannot compare it with mine and say, Doc, sorry, mine is wrong. Because you'll be the only one who has that. Do you know what I mean?
yes.
So you'll be making your own mistake and you wouldn't have any benchmark to check whether you have even made a mistake. So it's very important you double check these things one by one, verbatim, one by one. Paying attention to details. This is where paying attention to details matter.
Okay. Doc.
So go and change that in the Excel before you bring it here and then run the whole command all over again.
Yes, sir. Yes, sir.
Now, let me go back to command number 69 where we did. Christopher, you saw that I did the number of replications and made it 0, right?
Yes.
Okay. Now, I'm going to do another one and change the number of replications to be 100. It's not all the time these things work faster. I'm going to change it. I'm just going to do 100 replications. And then I run the results and see. So I'm going to do that. You guys don't have to do that yet. Okay, so now I just ran that and show the result. You will see that it's giving me now a different result. Let me go to the beginning.
Yeah.
Just want you to see if you were doing bootstrapping, what happens is the changes in the results. So where is the changes now? Well, it still gives me the efficiency scores as usual for VRS and for CRS, as you can see here. But right after that, it also now begins to give me the bootstrap score for the first one. So the first efficiency score if you check it carefully, you see that that first one, which was a V11, the value was 1, isn't it?
Yes.
Good. Now is now going to do a bootstrap of that score alone. So you can see that a bootstrap of that score now is giving us, and we are doing 100.
Mm-hmm.
So when you look at that first one, that is it. That first one, these are the top part of it. Of course, it's doing for each firm. And you can see that that score of 1, a bootstrapping is giving us these different answers.
Yeah.
Different answers. Up to 8, continue, up to 23, continue until 100. So 100 bootstrap samples for that has been taken up to 100. This is the last one, 96 to 100. And then that is for the first one, the first score. Then for the second score, it does the same thing. That's for B, bootstrap variable returns to scale of 2, what do you call it? In year 2. So own period in year 2. And you can see that this own period is also giving me 100 bootstrap samples up to 100. Now, after the 100, it now goes to the cross period ones. Okay, that one too, it gives what? 100. And then when it finishes, this is important. I wanted to know these things. Okay, when it finishes, it goes to, you know, all of the necessary ones. It does all of them, bootstrap samples for each one of them. That's what is giving me here. So you can see that when I did 100, it gave me 100. But when I'm doing 2,000, it would take some time.
Oh, okay.
So if you are doing bootstrapping, this is how you follow it. And you can see that it will give you the actual scores before it also gives you the samples, the bootstrap samples.
Yes. Yeah.
That is what it will do. Okay, for now, let me just remove the 100 bootstrap and maintain the 0. Oops. Maintain the 0, and then go and show the results once again. And this time, the results, it doesn't include bootstrap samples, as you can see here. Michael.
Yes, Doc. On the bootstrapping, after getting all these results, which of the scores will a researcher take?
Oh, we are going there. I'll run each one of them for you to see. We are going there. You are going to see the bootstrap, everything will be done by the software for you. It will tell you which one to take.
All right.
But Doc, please, after you run again the NREP 0, after doing the 100 and you came to do the 0.
Yeah.
For my side, I did the same thing, and I can see that there is a $sign with small I and D, and row 1 has been run.
This is what you are seeing. Is that not the same thing? Because after that, this is what I did, and this is what I'm seeing.
Yes, but at the end of this diagram, the last part.
The bottom.
Yes, the bottom. Okay, so I copied the here. Oh, you can see the A, B, C, D, E. My own was ranked B first, C, D, E, and A. So I wanted to ask why wasn't it in order as we typed it?
I don't know. I don't think it's a big deal. First of all of these scores that I'm showing you, by the way, you wouldn't need them. The actual score, these are components, so the actual score are now coming.
Oh, okay.
Yes. The real actual score are now coming. All right, so let's go to the next command. Okay. I've just left this NREP there so that you can always change it. We'll come back and change it and see the results anyway. But for the standard Malmquist score, let's go and look at the score properly. And that is command number 70 here, MMR. Once you run this MMR and ask the software to show you the results, I'm going to show the results by highlighting and then running. This is the results you get at the bottom here. No bootstrapping is here for now. This is a result. So the first results will give you the Malmquist score. The question is, what kind of Malmquist score is that? What kind of Malmquist? It is constant returns to scale. Constant returns to scale Malmquist score. And the value for firm A is 6. That is the value for firm A. The value is 6. What is the value for firm B? What is the value for firm C? What is the value for firm D? Now, please note that this is what orientation we are doing. Output orientation, right?
Yes.
Output orientation, you don't take reciprocals. Output orientation, down that you have the score of 0.6, it simply means that that firm deteriorated in productivity by 40%. Guys, do you remember when I was even showing you the graph? Or I should go back and show you. When I was showing you the graph, if you can remember, A was on the frontier in year 1, but in year 2, it came inside. Do you remember?
Yeah.
So if you are on the frontier of year 1, which means you're efficient, and then in year 2, you rather came into the frontier, it means that you have declined your productivity, isn't it?
Yes.
And that is what the score is saying. So for output-oriented score, whatever score you get, that is it. You don't take reciprocal. But for input-oriented score in Färe, for input-oriented score, you must take the reciprocal for growth to be more than 1 and for regress to be less than 1. But we are doing output-oriented. So what this means is that firm B had a score of what? 3. What does that mean? It means that productivity, firm B has improved its productivity by 300%. Is it 200 or 300? 200%, right?
Yes, 200%.
Good.
Yes, Doc.
200%. And then firm E has stagnated. So firm E did not improve productivity. How do you know that? Go and check the graph. Let me just show you something about the graph. When you go to the graph, watch it. You will see that E was on the same point as before. E1 and E2 was exactly what it was. It didn't move, it didn't change. Do you see that in the graph?
Yes, sir.
Yes, please.
So you see E1 and E2 is there. So no wonder its productivity change was 1. It stagnated. It looks like you people are now running things, right? So nobody is. All right.
Doc, we are following.
The next one is efficiency change. That is the constant return score. The next one is the technological change. You can see that they are all 2, 2, 2. So you can see that in general, every firm improved its technology in the constant returns. Please note that constant returns is not the graph I showed you. Normally, the constant returns graph is one straight line. And that's one straight line. Everybody improved its productivity by the same percentage. All right. Now we are done with the constant part. So the score will be the variable part. Watch the variable. So that gives you pure efficiency change. That's the first one. Do you see? This is a pure efficiency change. This is a scale. The scale here is a scale efficiency change. The one that Wheelock and Wilson called scale efficiency change. Then the pure dot tech. The pure dot tech is the pure technological change. VRS. And anything pure is VRS. And then the scale technological change is this. Who can tell me this last one here? This last one here, which one is that?
The Ray and Desli.
Scale change.
Of who?
Ray and Desli.
Ray and Desli, that's it. So this scale change of Ray and Desli, it is a multiplication, the product of the scale technological change and then
SEC.
what do you call it? The scale change. So this scale change and the scale technological change, these two will give you the SCH. But the way they have been arranged, once again, they don't look nice. So we are going to create a table and look nice. But before we do that, let's just go and see if we had done the bootstrapping. If we had done the bootstrapping, I'm doing the bootstrapping of 100. If we had done the bootstrapping and has shown the results, how would the results look like? And surely they will be different. So let's run that. So I'm now going to, the most important thing is command number 70. You see, 70 is saying that I want you to now give me the actual list of MM. And alpha here is the level of significance. And alpha is 0.05%. So you are creating a 95% confidence interval for the scores. So for each score, after bootstrapping Malmquist, you create a 95% confidence interval. Let's run that and see. So now that I've run that, let me go and click, show me the results. This is only results you're looking. And look at how beautiful it is. The same approach, but this time it gives you scores in confidence. So once again, it gives you the same thing I went through with you. That's it here. Okay, the same thing, it gives you all the scores without bootstrapping first. Then watch this. After the last one, after the SCH, okay, now it gives you CI.malm. Do you see that? Confidence interval for the Malmquist. So for the Malmquist, it's telling you that for the firm 1, it is actually between this value. Do you see that?
Yes, we do.
Please work with me, answer me, talk with me. I need to know that I'm talking to human beings, okay? Because that's the only way I'll be aware that I'm talking. All right. So you will notice that the score is 0.6 and 0.6. The confidence interval, you have the lower level and then the upper level. The lower. Yes, in this case, they are the same, okay? So no problem. It's not all of them, they are going to be the same. For example, if you look at the efficiency change, they are not the same. Now, the rule is that if the confidence interval includes is it 0 or 1? Hold on a second. If the confidence interval includes includes 0. It shouldn't include 0. Okay, it shouldn't. But let me just confirm that. So repeat your question, Michael.
Yes, I was saying that when we were doing the theory part, we mentioned that for output orientation, when the score is greater than 1, then the DMU is inefficient. But then when we came to the practical part, we saw a score of 3, and you mentioned that the firm has improved by 200%.
Yeah. So efficiency scores are above 1 for output-oriented. Their firm is inefficient. That is only the same interpretation for productivity scores. For productivity scores, when the score is 1, the firm has stagnated. And I'm talking about output-oriented scores. When the output-oriented productivity score is less than 1, the firm has regressed. When the output-oriented productivity score is greater than 1, like 3, 4, 5, 5.2, the firm has progressed. So that is how you interpret. So,
Doc, please say that again.
The output-oriented productivity score. Actually, productivity in general, when productivity in general is equal to 1, you calculate the productivity score and it's equal to 1. Okay. What it simply means is that the firm has not improved its productivity and has not declined in its productivity. So the firm has just stagnated. Do you get that part?
Yes, sir.
Now, when this score is less than 1, like 0.6, what it means is that the firm has reduced or declined in productivity by 40%. When the score is 0.6, okay, 1 minus that 0.6 is the value of the decline. And so 1 minus 0.6 is 0.4. So that means that the firm has declined in productivity by 40% between the 2 time periods. And the same way you interpret other productivity scores. Now, when the score is above 1, I'm sure somebody can tell me that. What does that mean?
That's a progress.
Colin, Senor.
It's a progress.
Yeah, it's a progress. I think somebody was disturbing us. So yes, that was a progress in there. And now, if it is, for example, 1.28, what it means is that a firm has improved productivity by 28%. That's what it means. The firm has improved productivity by 28%. So the estimate, now we are coming to, what do you call it? The bootstrap score. Are you ready for the bootstrap score interpretation?
Yes, sir.
So the bootstrap, you get a lower value and a higher value, sometimes the same value. Okay. So you now get a confidence interval within which the true productivity index is likely to fall. And Michael was saying that one of them, it was the same. Now that interval can be used for hypothesis testing. If you have done a little bit of statistical testing, you will know that you can use the confidence interval to help you to do hypothesis testing. And do you know that 95% confidence interval is the same as 5% p-value?
Yes, sir.
Alpha, sorry, 5% alpha level.
5%.
Yeah. Okay. And this alpha level is what you normally use to do hypothesis testing, as you know. And then we have the p-value. The p-value is normally compared against the alpha. And then if the p-value is smaller, then we reject the null hypothesis. I'm sure you know this.
Yes, sir.
Don't forget that. So we can use the interval, for hypothesis test to see if the change in productivity is significant or merely due to chance. Let me repeat that. For productivity bootstrapping, all you want to know is whether that change is significant. That's the key. All you want to know is what? Whether that change, which change? Whether the decrease is significant decrease. Whether the increase is significant increase. As for the stagnation, we don't talk about whether, it's significant or what. So the estimate of the productivity is said to be significantly different from 1 or unity. When we say it's significantly different from 1, what we mean is that there is no productivity change. And when is it significantly different from 1? It is significantly different from 1 if the confidence interval does not include 1. However, the productivity index is said to have significantly improved or declined if the confidence interval includes 1. If the confidence interval includes 1 in the middle, then we are saying that that increase or that decrease is not significant. I'll repeat that. I'll repeat that. So the Malmquist, the productivity is not significant. Is not significant if the confidence interval has 1 in it. I'll repeat that. Productivity is not significant if the confidence interval has what? 1 in it. Should I repeat that? You got that?
Yeah, I got it.
Productivity.
Doc, please
Uh-huh.
Does this only apply to bootstrapping?
Yes, because it's only bootstrapping of the scores that would generate confidence interval.
Okay, thank you.
So if
So
you are not
it's only bootstrapping that to generate
confidence interval, if you go and do normal productivity score, like cost productivity, profit productivity, or input productivity score, and the score is 1.8, you can only say the productivity improved by 28%, but you can't say productivity significantly improved by 28%.
Okay.
So the significance is as a result of that. So who can summarize what I said? When will it be significant?
Doc, you said it will be significant if the confidence interval does not include 1.
Good. So if the confidence interval, when you check the left and the right, the lower bound and the upper bound, if you check the value and the confidence interval, contains the value of 1, what does that mean?
Means the score is not significant.
That's the point. It means that whatever score you had, even if it is a growth, 1.6, even if it is a growth, that growth is not significant. Because it contains 1 in it. So the one that we have, where is that one? The one that we have here, if you look at the first one, does it contain 1 for DMU?
No.
So is it significant or is not significant?
Significant.
Number 2, does it contain 1?
So which one?
I've highlighted it in this thing.
Okay.
The DMU 2, the confidence interval for the Malmquist, does it contain 1?
It's 3.
It's 3. There's no 1.
Yeah.
So is it significant or is insignificant?
Significant.
It's significant. Now, number 3, is it significant or is not?
That one is also significant.
Number 4, significant or is not?
Significant.
It is.
Number 5, significant or not?
Not
Insignificant.
significant.
It's not significant. You got it. Now let's go to the efficiency change. Some of them can confuse you. Number 1, is it significant or is not? The efficiency change.
It is. It
the
is.
minus 0 point.
Is it significant or is not?
It is significant.
Hey.
It's not.
Because I said A, that's why you're saying it's not, or you understand. Okay, why is it not? It's not significant, by the way. Why is it not significant?
To 1.
Huh?
It does not include 1, or it's not.
Oh, you're rather turning the thing. I said it's not significant. And I'm asking you, why is it not? It includes 1.
I mean, I'm not seeing it.
If you are not seeing my screen, say you are not seeing my screen, not that you're not seeing the number.
Doc, how does it include 1?
You have negative 0.12 up to positive 0. Oh, okay, it's true. It doesn't include. Sorry. I need to have that. So yes, it doesn't include 1. So it's significant, isn't it?
Yes.
Okay. Let's go to the next one.
That one is insignificant.
That one is insignificant. The third one.
Significant.
The fourth one.
Significant.
Significant.
The fifth one.
Significant.
So you see, you can use these confidence interval of the scores. So when you are presenting the scores, normally you will present the scores in one column, and then you present for each score the confidence interval in another column. And you will know whether it's significant or it's not. And you can do the same thing for the technological change. All of these are constant returns. And when you go to the variable returns, you will also see that one here. For the pure efficiency, you get the scores for each one, all the way up to the end. And then those that are exhibiting infeasibility, you see them. Yes, Kizzy. Kizito, what's your question?
Yes, Doc. Thank you. I wanted to know why are we using. Yes, I wanted to know why are we using one as a criterion to judge whether the score is significant or not.
All right. Okay. So that's a very good question. First of all, do you remember we said that you are either progressing or regressing? You remember that? In life, you are either progressing or you are regressing, right?
Yes, Doc.
So when you are standing on your own, is that good or bad? When you are stagnant,
it's bad.
It's bad. So even though when you're efficient is good, in this year you're efficient, and next year too you're efficient. So if you want to find your productivity, what would have happened to your productivity? You'll be stagnant, right?
Yes.
And so if you are stagnant, what it means is that you're not progressing. We know that when you're declining is bad. We know, yes, we know. But that does not mean that when you're stagnant too is good.
Yes.
And so anytime you are stagnant, then it's like your score is constant. It means it's 1, isn't it?
Yes.
Good. Now, therefore, what it means is that if I want to know anything significant about you, as long as you are 1, it's like you are nothing, you are not significant.
Yes.
Because you are not changing. You are not changing. As to whether you are changing by up or down, that's a different thing. We know that changing downwards is also worse. But you are not improving, you are not changing. Yes. So you can be significantly bad and you can be significantly good. You agree with that?
Yes, I agree.
And so when the score contains 1, then what it means is that you are not changing. Some way, somehow, you are not improving. And that is why we use 1 as a criteria to determine the significance. Because once it contains 1, what it means is that you are likely to be that 1, isn't it?
Yes.
If it contains 1, if there is a range, and the range is -5 and then +5, what it means is that you can be 1.
Of course.
And if you can be 1, then I mean, remember, in productivity language, that is constancy. And that means you are not improving.
Okay.
And so that is why we use the 1 as a criteria.
Yes. Okay, Doc, but why are we not determining the probability of you being in 1 instead of just stating that you are not significant?
Why are you not what?
Because you say that you are likely to be 1 when
because you are in an interval. You are in an interval. The reason why I said you are likely to be 1 is because you are in an interval of which 1 is part.
Okay.
If I give you, let me just go and write something here. I pray this is able to work. If I give you -2 and then +1, -2 and then positive 3. You are likely to be 1 in this interval I've given you.
Yes.
But if I give you positive 2 and then positive 3, there is no way you can be 1.
Sure.
And when I say you are 1, what I mean is that you are stagnated.
Okay, understand. Understand.
It is on that basis that when the value includes 1, it is, we are not saying that is worse, but what we are saying is that it's not significant. Whatever value you had. So let's say that your score of productivity is 1.6. And then we check the score. And then when we check the score is between 0.5 and then 3. This score is between 0.5 and 3. And it includes 1. What it means is that this 1.6 can gravitate towards 1. And as long as it can gravitate towards 1, it means that 1.6 itself is not significant.
Yes. But it can be 2.
Yeah, but you can't tell what it can be. But if I give you a value like 1.6, and this same 1.6 is actually between 1.3 and then 3. As long as the lower bound is still above 1, you know that it can never be 1.
Sure.
So I can have more confidence in this 1.6 than in this 1.6.
Yes, of course.
Using the confidence interval. So the confidence interval helps you to know whether the value you originally had is significant or not.
Yes. Yes, Doc.
All right. Any question on this?
Thank you, Doc.
So that is how you're able to get all the scores. Anyway, now that we have gotten the scores, by the way, the bootstrapping part I brought in was just a digression. So but it gives you everything that you need. At this stage, you want to now get your results. You want to now get your results. You want to now put all results in a table. My computer is misbehaving. I pray that it doesn't go off again. Are we back?
Yes, Doc.
Good.
Oh, your screen is blank.
Okay. So there's one more thing that the software didn't immediately give us. And that is, did you realize that it gave us, let me just go back to the original scores. It gave us the Malmquist score for the constant returns. That's this one. But it didn't give us the Malmquist score for the variable returns. Do you realize that? Did you guys see?
Yes, Doc. Please, how do you differentiate the constant returns? Because there's no C or...
Of course, there's no C. But here is a rule. The rule is that it will always give all constant return scores first.
Okay.
And the constant return scores are only 3. It is a productivity score, the efficiency change, which is this, and then the technological change. That's it, finished. Everything else for you to know that it's variable it starts with the word pure. Anything with the word pure and the word scale is for variable. Does that help?
Yes, Doc.
But it doesn't still give you the variable, because when you multiply the pure, the scale, the pure tech, and the scale tech, when you multiply all these 4 of Wheelock and Wilson, you should get the variable return to scale score, Malmquist. But unfortunately, it doesn't give you that. The reason why it doesn't give you, I don't know, but I think it presumes that you can calculate it yourself. So in my command number 71, I had to calculate that myself. And that's what I have here. Calculating that myself. How do you calculate that? Well, remember that the variable returns to scale Malmquist, the way to get it is the pure efficiency change times the pure technological change. By the way, before I do that, let me go and rerun my score and get the non-bootstrap scores. I'm sure you know that the scores we are using now are the bootstrap scores.
Yeah.
I'm going to rerun it and then this time show the non-bootstrap scores. So when I run this one, you see that the scores are no longer the bootstrap scores, as you can see down here. All right. So I want to just generate my own VRS productivity score. And that is what command is saying. So command is saying that take the pure efficiency score inside the result. So that means that you need to go and see the results with your eye first. How do you see the results? Ooh. One way, let me see. If you type names into brackets, MMR. Let's see whether I can get the results. Okay, good. So you see, I type names into bracket MMR. That gives me all the possible results I should get in the Malmquist. And I know, you should know that the Malmquist VRS productivity score, I'm typing that, VRS productivity score or productivity estimate. You can see that that is the only way you obtain that is multiplying the pure efficiency change by the pure technological change. So what I did is that I take the pure efficiency change, I bring my multiply here, okay? I multiply that by the pure technological change, but I'm taking it from the MMR result and I run it. In fact, when you go and show the results, it will give you for each firm, it's the variable returns to scale score, as you can see here. So I want to create a table this time. You can create this table and send it to Excel, or you can create it, look at it here before you send it to Excel. So what do? You type RE for the result, print the results, column bind the results for me, and now you give the names you want to see. So I tell R that I want all the constant returns to scale scores. They start with C, C, C. Okay. Then you tell R that you want all the variable returns to scale score. They start with V, 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 V. So you get all of that. Let me just go here a bit. Then you tell R that you want the Malmquist results for CRS, that's this MC, you define it. Malmquist results for VRS. As for the VRS, you don't need to define it because you've defined it above here already in 72. Then constant returns to scale EC, technological change EC. You see, once you see EC, it's technological change, unless I write PTC. Once you see TC, it is for the constant returns. Unless I write PTC, then you know it's for the variable returns. So all of the parts are shown here, correct to 3 decimal places. Yes, Kizito.
Yes, Doc. Please. For the RE, can we do it in a for loop?
Can you what?
Do it in a for loop.
Yeah, you can do anything you want to do, yes. You can do, there are several ways you can create all of this.
Okay.
All right, so once you get these results, you can now take the results, to Excel. But let's watch the results here. So let's run this. Okay, let's run all of these results. And it shows you the results here. Watch the results down here. Watch it carefully. I like the way this results is showing. If I squeeze this thing to the right a bit, if I squeeze this thing to the right a bit, the scale change that has gone down will come up. So let me run the results again and then show. So I want all of them to be on one straight line. There you go. So you can see that all of these results are in one horizontal line. You have the own period constant returns, own period constant returns, cross period constant returns, cross period constant returns, own period variable returns, own period variable returns, cross period variable returns, cross period variable, the actual Malmquist under constant returns, the actual Malmquist under variable returns, then the decompose, the two-part decomposition under constant, then the four-part decomposition under variable. This is a four-part. The last one here is a Ray and Desli, which will replace the SEC and then the STC. Of course, infeasibility is in there. It was deliberate. And you can see that those that are infeasible, you have NA, 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 NA. Oh, this word, I should go and change the original one. It's supposed to be NA, not N stroke A. Guys, do you see the results? You cannot take these results to Excel straight away by copying it like this. Copy. Just straight away. I do this all the time. Oops. Okay, copy like that. Control C to copy. Then go to your Excel. Go to your Excel. Let me see. Okay, let me just go to Excel here. I just want to show you the same thing in my Excel. So I'm about to show you my Excel. I don't know whether you see. Do you see my Excel?
Yes, please.
Okay. So I'll do Control V to paste, but it will not be properly organized. So you go to Data. Okay. And then after Data, you click Text to Columns. Text to Columns. And then when you click Text to Column, you will see how the preview of the selected data looks like. Just click Next, and you see that everything has been nicely organized, into a cell. Now that you can preview and look at how beautiful it is, you click Finish. And there you go. Once you now see the whole thing, you can now see from here that everything is nicely organized. So you can arrange them, highlight everything, and click on it, and go and choose Center Alignment. Center Align. Everything will be nicely centered. Look at how beautiful it is automatically. You can also export it directly to Excel. And then go in and indicate which folder you want it to go, and you can go and watch it there. But at this stage, you can see that the Malmquist and everything is here. The rest is about interpretation. These are the key ones. So in your results, guys, in your results, I want you to show, this is a result I would like to see. This final one here, this results, let me just green or blue them. These blue results, these are what I would like you to show if you are submitting your work. For each DM, this is how you got to, sorry, each year, this is how you have to do. So this is for the year 2001, year 0, year 1, and year 2. This is it. So you have all of the scores, and then we'll later learn how to interpret these scores. If it was bootstrapping, what you are going to do is that when you show the score, then you show its confidence interval. When you show the score, you show its confidence interval. When you show the score, you show its confidence interval. When you show the score, you show its confidence, like that. And that one too, you will learn how to export it. That is how you do it. That is how you generate it. Any question on this? Any question? I'm sure you're all fine.
For now, yeah.
Yes. So what I've done is I've just shown you how to do all estimations of the standard Malmquist. Okay. Now, if the years are many, and of course the years are many here, if the years are many, how do you do the second year and the third year? Because we've done first and second year. How do you do the second and third? Guess what? Guys, do you see my Excel at the bottom here? I've written year 1, year 2. Do you see that? Year 1, year 2.
Yes.
Ah, good.
Yes,
this year 1, year 2 that I have here, that is how you will have to arrange all your data. I'm showing you the easy way out of some of these things. Year 1, year 2, this is how you indicate your data. Now, this year 1, year 2, there are 5 DMUs in each year. So that's what we just did. Okay, and then we just shown the results right here. In fact, one way you can do some of these things is that you can bring your entire results from here. You can bring your entire results here into that year 1, year 2, like this. Okay. Now, the next thing to do is that you go to another sheet and then use the year 2 and the year 3 data together. So you copy that here. You see, you copy that here. The advantage in this very example is that they are also having 5-5, isn't it?
Yeah.
They're having 5-5. And so you can go and use the same original command where you are considering one as the year 1 and then the other as a year 2. Do you get what I'm trying to say?
Yeah.
So you
Yes.
can.
Doc, it means you don't have to change the year 2 to the year 2 and year 3 here.
When you say you don't have to change what?
From what you said we can use the same command that we use.
Yeah, so you didn't say you don't have to change. You say you don't have to change the command. That's what I want to hear.
Okay. Okay.
Yes. So in this very example, you don't have to change the command. But if the third year was maybe 6 DMUs, then in that case, you have to go and still change the command slightly.
Yeah.
You get a point?
Yes.
Yeah.
In that case, you have to change the command. So normally I advise I have 3 possible different commands. The same thing, but 3 different times. So that when you see where some of the samples are more or less, then you can edit one. And you don't have to create every command for every year. So suppose you have 20 years, then you're going to create a command. But the thing is that you still have to get 20 different Excel sheets, each one containing 2 pairs of years. Each one having a pair of years, a pair of year. So that you can take them into the clipboard and then just run it. When you run, you come and bring the results, you bring the results here, and then you can go back and continue with the others. It takes time, but it's better. I've been doing that for 20 years, for 30 years, for 40 years. I've been doing that. You got to get used to that. All right, so that is it. So if I wanted to do this here, I'll just have to copy this one. Okay, go to my R and run the same thing, get the results properly arranged and bring the results here. Boom, just like this. And the results will be different. The results will be different. Then I'm organizing it. When I'm done, I will now organize all of them at the go. So these are yearly. Once you are done, you will do all averagely. And you take the geometric mean and then do all completely. But your final results is going to be the ones in blue column here. All right. The last thing I want to say about this is that when you identify infeasibilities, okay, you will ignore them and deal with them later. You ignore the infeasibilities and then you will deal with the infeasibilities later. You go back to the R. So for those who run the bootstrapping, you notice that I didn't bring the bootstrapping here. But if you are doing bootstrapping, you have to add the bootstrapping to this table. And once you add the bootstrapping to the table, they go along with the one in the table. And of course, there are several examples that some of your colleagues have done and did have bootstrapping. Okay. There are several examples. Let me just show you one. Okay. Sometimes the bootstrapping, instead of using the confidence interval, you can also have the bias. In fact, you should have both actually. So let me show you an example. So this is an example by one of my students. And what he did was, okay, you see the table? You see the table?
Yeah.
Good. Yes. So in this table, you see that he has the year, and then this is the efficiency, the productivity score, which is stagnant. Okay. And you check, the confidence interval. Watch the confidence interval. It is including that one. So it means that that firm exhibiting the one is insignificant anyway. And then if you look at the second one, productivity was 1.16, which means the firm improved productivity by 16%. But that 16% productivity improvement, is it significant? Well, the easy way is that he has put 3 star there to tell you that it's significant. But he did that by checking this lower and upper bound. Okay. And you can see that the lower bound is 1.09, the upper bound is 1.23. So it kind of looks like it is almost becoming insignificant, isn't it? Well, yeah. This one doesn't include 1. Okay. But what I mean is that it almost included 1. But whatever it is, it's not 1. And that was big, not 1. And so this one was significant at 1% or 0.1%. So those that are insignificant, you can see them. For example, this one was this very one example, the 1.2, sorry, 1.02, this one. It was productivity progress, 2% progress. But if you look at the confidence interval, that progress was not significant. That progress was not significant. And if you look at the last one, it was significant at 10%. So that is how you represent some of your scores. And I want you to take note of all of this. But the most important thing, yes, go ahead.
The confidence interval says it's 95%, which means that we are looking at a 5% alpha level. But then the scores, whether it's significant or insignificant, we see that there's a 1% alpha level, 10%. Yeah. So how did the researcher come by that, since we are just looking at a 95% confidence interval?
All right, so it's very easy. When you run the thing quickly, let's say you run something, and that thing, normally you would check first at 1%.
Okay.
And sorry, not at 1%, 0.1%. And you want it to be significant at 0.1%. That's what you want. That's what you love. That's what everybody loves. But so when you do the 0.1%, it's not significant, then you go to 1%. When you go to 1% and it's not significant, then you go to 5%. If that's not significant, you go to 10%. So what a researcher does, you can easily do that. Okay, you can easily do that. How? Okay, so one way you can do that is you can use the bias. I'll tell you a little bit about the bias later on. But you use the bias, and in the command, guys, look at here. Do you realize that here I had 0.05 in command number 70?
Yeah.
It's just 0.5. So I can just change this one to 0.1. I can change this one to 0.01 easily and run the thing. And then go and check.
Oh, okay.
Once you change these things, you already have. But the standard one is 95%. So you still want to maintain the 95% confidence interval. And then the other ones, if they are working for you, then you show them. If they are not working. So you can see that the author didn't show for 5%. You get a point. But he shows for 10%. Because none of them was significant at 5%. And normally, for the person to come and show it at 5%, he has already shown at 0.1%, 1% before the 5%. And once 5% is saying that the thing is not significant, okay, you go to 10%. 10% says it's not significant. So when you actually start with 10% and 10% say it is significant, that is good. Then you go further and go and check 5%. Because 5% is better than 10%.
Yeah.
And 1% is better than 5%. No.
Sure.
So that is how you do your Malmquist analysis. And that is how you generally. The rest is about interpretation. But even that, I've still spoken a bit about the interpretation for you. Okay. What does progress mean? What does regress mean? What does significant progress mean? What does significant regress mean? I'm sure you got it all today.
Yeah.
Any question?
Doc, is there an insignificant progress? Can you be stating that in your work?
Yes. You can say that there was a progress, but this progress was not significant. Yes.
Okay.
Yes, you can. In fact, normally when you have progress and these progress are not significant, you don't have much to say, to be honest with you. You only have to say that there was a progress. But once you incorporate bootstrapping, you have to talk a lot about significance. You have to talk a lot about significance. If you don't talk a lot about significance, you're in trouble. Okay, once you are doing bootstrap. But if you are not doing bootstrapping, you have not spoken about anything, then fine, you are not showing any confidence interval. Okay, fine. But don't go and use the word that there was a significant progress. You get a point. Don't go and use such words. Because those are statistical bootstrapping words.
Okay.
Very good. Since you are happy, and I'm happy,